Welcome to this Architecture Today webinar, Intelligent Specification for a Zero Carbon Future, with our content partners MEDITE SMARTPLY, and introducing your chair for this event, Ruth Slavid.
Hello, welcome. I'm really pleased to be chairing this today because I think this is probably the most important issue for all of us at the moment. It's on our minds, of course, in the wake of COP26, when I think we've come out both hopeful and a bit worried that although some of the agreements that have been made are a bit of a compromise, we're hoping at least that we can achieve what has been agreed. And I think we all know that in order to achieve that, it needs to come from government initiatives, government commitments, and then also the very small details of what everybody individually can do. And that's why I think this is going to be such a very interesting event, because we are going to be looking at it at every scale. We are going to be drilling down into it from a national and international level. We're going to be hearing from Daria Blanc-Mathieu, who is a sustainability consultant with Meehan, who is looking at things from the point of view of products. We're then going to be looking at a specific product through David Murray of MEDITE. And then we're going to look at how products are used in one specific building from Isabel Barros of Isabel Barros Architects. So I think that's a really interesting way to be working. And all it remains for me to do is say that in this, from the broad to the narrow perspective, we are starting with a presentation from Pat Barry, who better than the Chief Executive Officer of the Irish Green Building Council. Pat.
So we are the Irish Green Building Council, and just a brief introduction to ourselves. We're a membership-based organisation in Ireland with over probably close to 300 corporate members. And we do a range of activities from inputting into government policy. We run a number of certification tools, such as Home Performance Index. We run an environmental product declaration program. And we do a lot of education and training, helping the construction industry transition to a sustainable built environment. We're a member of the World Green Building Council, which is a network of over 70 green building councils around the world, which are individually trying to move their markets towards sustainability. I suppose one of the things that is very hot topic at the moment is the conference in Glasgow, which has just completed. Now we are already required to meet a target of net zero by 2050 within Europe, but in order to stay within 1.5 degrees global warming, we need to move very, very quickly, and that means really over the next 8 years, we need to cut emissions by half, and then very rapidly get to zero. At least by 2050, if not before then. So everything is now about how do we get to net zero emissions. So within the construction sector, that is a particular challenge because not only do we have the issue of cutting operational carbon emissions within our existing stock. The global stock is expected, the global floor area is expected to double by 2060 in the period that we are trying to cut emissions. So not only do we have to cut operational carbon emissions to zero, we have to cut the embodied carbon emissions of constructing all of these buildings to zero as well. So that is a real challenge. So I suppose within Europe is probably been the first region to really start to look at this, and a number of countries are moving towards regulation. And the European Commission itself are trying now to, through the European Green Deal, to really start to look at transitioning the whole construction sector and the material supply chain. And as part of that, we are collaborating with 10 green building councils across Europe, including the UK Green Building Council, who published a roadmap last week on getting to net zero carbon with the across the whole life cycle of the building stock by 2050. So we are collaborating together on how for each country we develop a national roadmap to get to zero. Now, one of the aims of this project, Building Life, is to set out a plan to stay within 1.5 degrees for Europe's building sector. And I suppose one of those impacts is that we want to have is to get the European institutions to start to require all Europe's countries to start requiring those countries to regulate embodied carbon. But we would like to have at least 5 additional countries within Europe implementing regulations around whole life carbon. We already have Finland, France, and the Netherlands who have already or are in the process of introducing regulations. And part of this is building a momentum around it, getting all of the leaders in those countries to help us get the message across. So within Ireland, what we are doing is we have signed up politicians, the leading CEOs of developers, the CEO of the construction institutes, such as the RIAI, to sign up to promoting the whole concept of whole life carbon and getting to net zero carbon emissions. Now, globally, the construction industry and the property sector and the buildings are responsible for about 39% of global carbon emissions. And that's made up of 28% carbon emissions from the operations of buildings and about 11% from the construction of new buildings and the maintenance of existing buildings and infrastructure. So that's everything from the manufacturing of materials to the transport of those materials to the integration of those materials on the building sites. Now, we had been slightly annoyed in Ireland as we were using these global figures, but we didn't know, is that really the case in Ireland? In Ireland, for example, we have very high agricultural emissions, so we assumed that the emissions from construction would be somewhat lower. And I know the UK have done the same exercise of trying to measure what are the emissions associated with construction, because the way countries report their emissions to the IPCC is they do it by sector. So they do it by transport, by industry, by electricity generation. So it's quite difficult to tell which of those emissions are related to construction, because industry covers everything from making consumer goods to making construction materials. So we commissioned UCD, one of the universities here, to carry out the study for Ireland. And what we found is the emissions profile, based on a very initial analysis, is quite similar. At least 1/3 of our emissions are associated with the construction and buildings, 24% for the operation of buildings, and about 11% again for the construction of buildings and infrastructure. Now, it is quite complex because some countries like Ireland and Netherlands are countries like Netherlands or Ireland or UK import a lot of materials and export a lot of materials. So in Ireland, we export a lot of precast concrete, but we also import a lot of steel, a lot of aluminium products, glass, etc. So these figures are based on consumption, not on production within the country, but they're probably roughly similar. And when we look at the construction of buildings and embodied carbon, we're looking at material extraction, material manufacturing, the distribution and transport, the use and the waste management. Carbon emissions result from all of these stages of the building life cycle. And just to give you a rough estimate, for every square meter of office space we build, it's somewhere roughly around 775 kilos of carbon per square metre. If we're looking at residential, under current practice, it's probably, well, certainly in Ireland and UK, it's probably around 500 kilos, about half a tonne upfront carbon emissions. So when we look at, say, the emissions profile for Ireland, that is expected to rise. So we're currently coming from a very low base in 2010 for construction, and with a continuous trend that is rising all the time. And as we go towards 2030, the quantity of construction will rise further by at least 50%. So at the same time that our construction levels are rising by 50%, we have to cut our carbon emissions by 50%, which is quite an ask. And this breaks down, if we look at our National Development Plan, into different sectors. So if we look across all of just infrastructure, our roads construction is way out in front. Road maintenance is quite high, quite a high program for development of healthcare. But you can see the range and the type of construction that will result in upfront embodied carbon emissions. Even the development of solar infrastructure, wind power, do result in the construction of those construction of that infrastructure, which is necessary to decarbonize the built environment and decarbonize countries, also results in additional embodied carbon emissions. So if you look at, say, just the residential sector, our target is to renovate 500,000 homes by 2030. Deep energy renovation, well, each one of those deep energy renovations will result in carbon emissions as well. So if you look at the blue band, that is the impact of reducing emissions from operating homes, because we're carrying out these retrofits. But then if you look at the orange band, that is the emissions associated with the embodied carbon of carrying out those renovations. And if you look at the light orange band, that is new construction of new homes. So that means whilst the emissions for operation are falling, the emissions from embodied are in fact rising and slightly offsetting some of those emissions. So that means we have to be very careful about carrying out a whole life cycle assessment to minimize those emissions as far as is possible. And then looking at all sectors, whilst we are reducing emissions from across residential, commercial and public by being more efficient, there's a danger we will miss our targets unless we also focus on those embodied carbon emissions. And that really means kind of a revolutionary approach to how we construct buildings, how we renovate buildings, in order to hit our targets of 51% reduction within 8 years. Now, I did mention already, a number of countries have already moved towards regulation. France, 2020, introduced their regulations, E plus, C minus. Holland has actually had regulations in place since 2016, and they were, since 2011, they've had a requirement to carry out an LCA on homes and offices as part of the building permits system. Denmark is also introducing regulations, and Finland and Sweden are introducing regulations on whole life carbon in the coming years. So countries are moving quite quickly towards this. UK and Germany has had requirements for public buildings, I suppose, more recently. In Ireland, the Climate Action Plan was published 2 weeks ago. And in this, it sets out a number of actions that are moving us towards whole life carbon measurement. So these include actions on cutting the embodied carbon emissions of products by between 10 and 60%. Well, that's more of an indication that they haven't worked out the details yet, but they know they need to, and it's likely to be at the upper edge of that scale, more towards 60%. They will be including regulations in all public buildings for measurement of embodied carbon, and looking at developing a methodology for measuring whole life carbon, probably aligned with the EU levels framework. And they will be supporting a tool, probably the one we are about to launch in the next week or so, to support early stage comparative analysis of embodied carbon in typical Irish construction typologies. So we are moving also in that direction, and it is likely that most of Europe will move towards regulation of embodied carbon and whole life carbon in the next couple of years. That's also supported by the different institutes. The RIBA published their 2030 climate challenge in 2019, updated it again this year. The Royal Institute of Architects in Ireland have adapted that and published that a couple of weeks ago, and Irish architects now have targets for embodied carbon and operational carbon in Ireland. They're aligned with the LETI benchmarks. So one of the things that really going to have to happen over the next couple of years is we're going to need a revolution in the type of material we use, the type of construction methodologies that we use. So there isn't really any way we can achieve an order of magnitude of 51% without incredible levels of innovation in the construction sector. And to facilitate this, one of the barriers we see is that every architect now has to be upskilled to understand how they can reduce embodied carbon, and that'll require simple tools that allow them to optioneer and evaluate at early design stage how they can reduce, compare one type of construction versus another. It may not be a case that every architect will get into detail accounting, but at early concept stages, stages 1 to 4, they will need to have an understanding of, if I use this construction methodology, or what the impact of the form of the building, the shape of the building, the type of foundations will have on the embodied carbon. And this is one of the reasons we are introducing this free tool to the Irish market. It's only accessible, unfortunately, to Irish users, and this will allow them to carry out early design optioneering and compare quickly what the impact of one using, say, a timber floor versus a concrete precast floor, etc. And then at the end of that, they will get a simple life cycle assessment evaluation at early concept stage, and then that can iterate it as they go through the various stages, through to tender and through to completion. The thing is, most of the embodied carbon emissions, most of the early design stages have a very big impact on how you reduce embodied carbon. So it's really vital that that is done as early as possible. And we were coming from a situation, for example, in Ireland, where we had no data on products and materials. So one of the steps we have taken is to develop generic data for typical high impact products that are used in Ireland. And by the development of environmental product declarations, we have had quite a successful program here, which means that most of the major manufacturers, we don't have a huge construction manufacturing sector in Ireland. It's quite small, but we produce for over 40, probably by the end of the year, about 60 environmental product declarations, but that will cover probably the majority of the major manufacturers in Ireland and most of their products. So we now have the data, we have the tools. Now it's just a question of getting architects and engineers to use them and to transition towards low embodied carbon construction. The next step is really to transition the whole construction supply chain towards low carbon materials. The next thing is digitalizing. We've digitalized all of the EPD. We've connected them up with the eco platform. So this will allow the development of new tools to make it easier to assess embodied carbon, because all of the data in EPDs is now freely available from the programs that are signed up to eco platform. So if you develop a new innovative tool, you can easily download all of the data to help you develop new innovative tools to help architects. So thank you very much for that. I'll answer any questions in the panel.
Thank you very much. I think that's both exciting and daunting when you tell us that we need a revolution in construction. And as you said, yes, there'll be lots to talk about in the panel later. Everybody, please, if you do have a question, do send them in. There's a question button that you can hit, and obviously we will look through all those questions at the end and pick the most relevant and interesting ones. I think we have started in a fantastic way, indeed in the way that we intend to continue. So with no more ado, I'm going to pass you to our next speaker, who is Daria Blanc-Mathieu, who is Senior Sustainability Consultant with Meehan Green. Daria.
Thank you. Good morning, everyone. I will talk about selection of building materials and how it can help to achieve COP26 goals. First, I would like to introduce you Meehan Green. We're an independent consulting company, and we're not doing any design services in-house. We're mainly specialized on green building certifications and life cycle assessment. We're working on site rating systems as LEED. We also have LEED proven provider, only one in Ireland and one of 7 in Europe. We're also working on WELL, on BREEAM scheme and HPI. And we also can help to define and achieve carbon targets to our clients, both embodied carbon via life cycle assessment and operational carbon via energy modeling. Now let's talk about COP26 goals and how selection of building materials can help to achieve them. And the first goal is to achieve net zero by mid-century and to keep 1.5 degrees within reach. So on this graph, you can see how dramatic the actions that are required to achieve this target and how limited amount of time is left. That is why I would like to emphasize how urgent is that to take an action. And obviously, selection of building materials can help either to achieve this action or not achieve. The second goal of COP26 is to adapt communities and to make them resilient to climate change events. As you know, the people who are affected the most by climate change events are those living in developing countries. So let's look into example here. On the left side, you can see a picture of Kumjun village in Nepal, which is taken after earthquake in 2015. And on the right side, you can see the project of the school refurbishment in the same village. This project was done by Shigurban architects, and they decided to use timber frame for this building because it can take horizontal loads in the case of earthquake, and that it can allow for movement instead of collapsing. So in this case, the choice of material for the structure was good, and it helped to provide the children with safe spaces. Now let's focus on carbon. As you know, 28% of emissions are coming from building operations and 11% are coming from building materials and construction. However, if we're going to achieve net zero by 2050, this figure is going to change. Operations emissions are going to go slowly down towards zero, and at 2050 there will be no building operations emissions anymore, and all emissions will be coming from building materials and construction. On this graph, you can see the distribution of embodied and operational carbon emissions throughout the life of the building, which is typically 60 years, and this is for a typical office. So you can see here the embodied carbon emissions coming from A1, A5 stages, extraction of raw materials, their transportation to manufacturing plant, manufacturing, transportation to building site, and then construction. Then you can see emissions that are happening due to replacements of products throughout the life of the building and end-of-life emissions. And here are operational emissions that are distributed throughout the life of the building. And the red line is scenario that will happen if we're going to achieve net zero by mid-century. So operational emissions will slowly go down towards 2050, and then there will be no operational emissions anymore. So on this graph, I would like you to note how big and how important are these emissions that are coming from A1, A5 stages. And the one thing is that they're big, but the other thing is that they're not distributed throughout the life of the building. They're all happening right now, today, when you are building your building. And global warming is also happening right now. And obviously, these emissions can be influenced by the selection of building products. Okay, so we want to decarbonize our building. So where do we start? How do we choose which materials to prioritize? To know that, we start by building the baseline model. Baseline model will show the typical construction for the region where the building will be constructed. So here I would like to show you an example from one of our projects. This was office building in Dublin, and it had a steel structure. So you can see that the most important material in terms of carbon emissions is structural steel. The second material is ready-mix concrete, and the third material is raised access floors, which you may find untypical or strange, but I will explain you later why that happens. So now we know which materials we want to target and which building elements we want to target. So what are the solutions? What are the options to decrease the carbon? The first and very effective option is to use bio-based or natural materials. First of all, these materials typically have lower embodied carbon than human-made materials, which require high energy-intensive processes to manufacture them. Secondly, these materials are renewable. For example, if you are using timber structure for the building, you can plant trees again and you will have timber later. And additionally, they also have biogenic or sequestered carbon. However, according to most of the building regulations, we cannot take advantage of this carbon in the results of our life cycle assessment. We cannot simply subtract it from the total. For example, here you can see insulation materials, and you can see that natural materials, they have negative carbon. But when we do whole a building life cycle assessment, we're not going to subtract that from the total, but we're going to report it separately. And that is due to end of life of building, which cannot be guaranteed and is not controlled by us. How can we guarantee that the timber, for example, will not be burned at the end of life? And if it's burned, the carbon which is stored in it will be released back into the atmosphere. So the first thing here to note is that obviously it's better to design and construct our buildings in a way that they can be disassembled at the end of life, and the materials can be reused or recycled instead of going to waste to energy or to landfill. However, even if our timber is going to be burned, I would like to note that emissions are not going to happen right now, but they're going to happen at the end of life of building in 60 years from now. So the emissions are shifted in time, and that is also positive. I would like here to show you an example from French building regulations, which will be in force from January next year. And their methodology will take into account when the emissions are happening. So the emissions which are happening right now, they have higher impact on global warming potential than emissions that are happening, for example, 25 years from now. When we say bio-based materials, most of people think only about timber, but I would like to note that there is diversity of natural materials that are available for construction. Let's just look into some examples. The first example is COP26 house. It is built using SMARTPLY OSB, and David from SMARTPLY will talk more about this product later. The second project is Rediscovery Center in Dublin, which is built using hempcrete. And this is Straw Bale House. This is 5 floors public building in Paris, which is built using earth construction. And then this is a greenhouse, which is built using the tubes, structural tubes, which are made of recycled paper. Here, I would like to show you an example from one of our projects where we studied the typical floor slab. So we tried to choose the option which will suit better for the project. As you can see here, the steel frame solution was the worst in terms of carbon. Then when we tried to use Weststock beams, because of you have less usage of material, we have better results. And then both concrete options were looking better than the steel options. And in this case, actually, PT slab was looking worse than reinforced concrete slab because structural engineer designed it with lower GGBS percentage. And the best solution for this project was CLT. And biogenic carbon or sequestered carbon is not taken into account here. In some cases, you cannot use bio-based materials. It may be because of the specific country regulations or because of specific project requirements. For example, for manufacturing facilities of medical devices, you cannot use fiber-based materials. So it can be challenging to use natural materials there because otherwise you have to enclose them. And if you're enclosing them, you're adding carbon again. So in this case, you may have to use steel or concrete. In the case if you are using steel structure, you still can improve it, you still can decarbonize it, depending on which steel you're going to choose. You can see here that if you are using steel coming from electric arc furnace, the emissions are much lower than from the steel that is coming from BOF furnace production. And you may ask about availability, so I can tell you, for example, in our projects in Ireland, engineers are saying that it may be difficult to ensure that 100% of steel will come from electric arc furnace, but 90% of steel coming from electric arc furnace is a reasonable requirement and can go into specifications. What if you want to improve your concrete elements of your building? You can see that depending on how much recycled binders, GGBS or fly ash you will put into your concrete, you can actually improve a lot the embodied carbon of your concrete mix. So these are all mixes for the same concrete strength. And you can see how much embodied carbon can drop just by adding more recycled binders. And then I would like to talk about the strength gain of concrete with different quantity of GGBS. Here you can see that at 28 days, concrete with 50% GGBS will have the same strength gain as concrete without any GGBS at all. So that means that in most of the project, for most of the building elements, you can actually use 50% GGBS without having an effect on construction schedule. And at 56 days, you can see that concrete with 50% GGBS will actually have higher strength than the concrete without any GGBS or with lower amount of it. Now I would like to talk about raised access floors. You probably remember on one of the slides that I said that on one of our projects, the raised access floors was the third most important element in terms of carbon after steel and concrete. So that is related to its replacement factor. Because you don't keep this product throughout the whole life of the building, but you have to replace it several times, you basically triple its emissions. So that's why it becomes so important. And on this graph, you can see emissions that are related only to before stage replacement. And you can see that the horizontal elements of the building will have highest emissions, and that is related to raised access floors that are used in the office building. And you can significantly decrease these emissions just by using a different product from different manufacturer, which will have better values in terms of carbon. Now I would like to talk about ceiling solutions. In some cases, you have to use metal ceilings. Again, for example, manufacturing facility of medical devices. But even if you have to use metal ceilings, you can improve them by using, for example, a steel ceiling instead of aluminum ceiling. But in most of the cases, you don't have to use metal ceilings, or you even don't have to use any ceiling at all. It is obvious for such spaces as storage spaces or fire escape stairs, but even for some occupied spaces, you can use exposed ceiling and it can look nice and modern. Otherwise, you can use timber ceiling, and this is example of the ceiling with SMARTPLY OSB, and it also has very good values. And otherwise, you can use plasterboard ceiling. To conclude, I would like to say that there is no one single solution that you have to apply for every project. There are thousands of different options, and you're only limited by creativity of design team and life cycle assessment consultant. Thank you very much.
Thank you very much. Again, a lot to think about. I have to say, one of the things I always wonder about is with these cement replacement materials, they all seem to be byproducts from fossil fuel plants. And I'd be interested to see what we're going to use when we actually become more reliant on renewable energy. The sooner the better, obviously. That's something that's occurred to me. Others of you have been thinking of other questions. We've had some really interesting ones come in, but do keep those questions coming as they occur to you. And we are now moving on to our next speaker, our third speaker, who is David Murray, who is Head of Technical Affairs and of Ireland Sales at MEDITE SMARTPLY. David.
Thanks, Ruth. I'd like to reflect for a moment, if I may, just to set the scene, particularly for any younger people on the webinar or for any newcomers to our industry. I've worked in the timber industry for almost a quarter of a century, and in that short space of time, I've witnessed a housing boom followed by a crash, followed by a lengthy recession of almost a decade, followed by a period of sustained regrowth at more sustainable levels, and more recently followed by a pandemic which pretty much grounded the construction industry to a halt once more. And right now we're experiencing huge housing demand and even bigger demand for quality wood panels. Wood is a precious natural material, and as the title says, it's also the carbon smart building material, but it's only the right choice if it's been sustainably sourced, responsibly sourced, if it's used in a resource efficient way, and if all of the required quality and sustainability standards have been met. And it's only when these basic criteria have been met can we really understand the true potential that exists for wood panels and wood products in delivering zero carbon buildings at scale. So in this presentation, I'm going to give you a very brief overview of MEDITE SMARTPLY. We'll try to delve into embodied carbon in a little bit of detail, understanding the carbon footprint in EPDs or environmental product declarations, and see where that meets up with operational carbon of buildings, followed by a very quick introduction to Project Net Zero, which is recently being launched by MEDITE SMARTPLY, and we're delighted to be working with the next speaker, Isabel, on that case study. So more on that later. So firstly, a very brief overview of MEDITE. MEDITE SMARTPLY is owned by Quilcha, which is the Irish state-owned forestry company operating in forestry and land-based land solutions, and also wood panels manufacturing. So the Quilcha Forest Estate is approximately 440,000 hectares. So our feedstock is guaranteed from our own forests. And here you can see in the picture, this is MEDITE in Clonmel. You can see a picture of an extensive log yard and wood chip yard. We manufacture a range of MDF products for internal applications, such as shop fitting and joinery and furniture and so on. But incredibly, we also make a panel that is guaranteed to last 50 years outside, which is a really good example of how we can bring a product like that to last longer in buildings, which really adds to the circularity benefits of wood and MDF. Looking at SMARTPLY then, based in Slieve, County Kilkenny near Waterford, again, the feedstock comes from our parent company Quilcha, and here we make a OSB or oriented strand board, which is a structural alternative to plywood, which is typically imported from different parts of the world. So now we get into a little bit of the detail about wood as a smart building material. Wood is a carbon negative material, and we'll get more of that detail later on when we look at the EPDs. We start off by saying that 50% of the dry weight of wood is carbon, and that carbon gets stored in the products that we make. And if we look at the picture on the left here, this is the typical quality of logs that come to our factories from the forest. As you can see, they're very small diameter, what we call pulpwood logs. And these logs capture carbon as the trees grow, and they sequester that carbon in the wood products. So we grind the logs down into fibers for MDF and strands for OSB. We add resin, wax, and other additives to make high quality wood panels in a range of applications such as flame retardant, moisture resistant, and exterior properties, as well as things like low formaldehyde. There's two important points on this slide here. I mentioned the logs on the left-hand photo. These are small diameter pulpwood logs. These are typically come from the first and second thinnings of a forest. And forest thinning is a really important forest management practice. You basically take out the smaller, weaker trees to allow the bigger trees the natural light that they need to grow to their full potential. So you increase the forest yield, and you also reduce the time to clear fell. But those logs, which are now pretty much worthless on the forest floor, then become a very high value feedstock for MEDITE and SMARTPLY in wood panels. In the middle picture, you see the log yard in, the wood chip yard in MEDITE. And again, this is a byproduct of the sawmill industry. So about 60% of the wood that goes into MDF comes from sawmill residue. And that's a really good example of what we call pre-consumer recycled content. So both of these sources, the logs and the wood chip, are basically a byproduct or a waste or whatever you want to call it from the forestry and sawmilling sectors. And actually that's how MEDITE came about in the early 1980s. MEDITE was built as an outlet for this low quality wood, and we turned it into high value wood panels. And they're even becoming more valuable nowadays, obviously, when you bring carbon into the conversation. So if we look at the annual carbon storage in our MDF and OSB, so starting on the left-hand side here, we can see CO2 being emitted by our homes, by our cars, by our factories. We all learned about photosynthesis in school, so we know that trees suck up this carbon dioxide from the atmosphere. The tree, as it grows, holds onto the carbon within its structure and releases the oxygen back up into the atmosphere to give us the clean air that we need to breathe. Next, we look at in this section, to make 1 cubic meter of MDF, is half a ton of carbon dioxide is sequestered in that volume. And 1 ton of CO2 is sequestered in 1 cubic meter of OSB. And when you bring that together into our total annual production of MDF and OSB, which is 800,000 cubic meters or thereabouts, that's the equivalent of 750,000 tons of carbon that is stored or sequestered in our wood panels. And that's the equivalent of 1.3 billion litres of petrol, if you assume that 1 litre of petrol emits 2.32 kilograms of CO2. So it's a really good story in terms of carbon storage, and we're going to look at that in a little bit more detail later on. But first of all, some breaking news, I guess. As of last Friday, the Irish government announced their climate action plan, which has a range of measures here aimed at promoting the uptake of low carbon construction. And I'm not going to go into them in detail, but it's great to see that finally we're getting our wood is getting the opportunity that it so deserves and being built into regulations. So looking at promoting sustainable construction products, limiting and measuring embodied carbon emissions from building products and projects, increasing the use of low carbon materials, and so on. And it's there's also examples in here where the government is looking for leadership from the industry to design and build exemplar public sector buildings using alternative construction techniques and materials, and importantly, I think, to monitor their performance, because I think that's critical as we move forward. And in the UK, the industry has basically come together and said, here's how we can tackle embodied carbon. Industry groups have written what we call a proposed approved document. It's not an approved document yet, but it's a proposal being put to government to say, look, here's a document aimed at reducing whole life carbon in buildings, and they've pretty much done the work, worked it all out, and that's the way we need more leadership of this type. In other countries like France and the Netherlands and Finland, they have already started to build regulations into their building regulations to limit embodied carbon in construction. So if it can't be measured, it can't be reduced. And this is what I suppose this presentation is focusing in on, is EPDs, or environmental product declarations, and trying to understand what's in them and what the output means in a real life context of a building project. So this is an EPD, is a declaration of a material's carbon footprint. It's the output of a life cycle analysis, which is EN 15804 compliant. And what we call, there are different types of EPDs. There are generic EPDs, and then there are product specific or type 3 EPDs, which have been independently verified by a third party. And this is an example of MEDITE SMARTPLY's EPDs are type 3 EPDs. They're completely voluntary. What this does is it provides transparency. So this is not a guarantee that the product is any greener than any other product. It is simply providing a transparent picture of the global warming potential of that product. And this eliminates greenwashing, because people can then make up their own minds on the quality of the product. Typically, as I mentioned, there are generic EPDs, but typically the GWP values, or the global warming potential values, that are in type 3 EPDs are lower than they would be in generic EPDs, to the tune of around 20 or 25%, as has been evidenced in Scandinavia. The EPDs are published on the European EPD database, basically on EPD Ireland, and also on the Eco Platform websites. And crucially, we've made these available in digital format as well. So that feeds into whole life carbon assessment methodology softwares, which are being developed or which are already on the market. So this enables whole life carbon assessment of buildings. And this is MEDITE SMARTPLY's commitment to sustainability, eliminating greenwashing. So the onus is now on specifiers to demand EPDs. If you don't ask for them, manufacturers won't deliver them. So the onus is on specifiers to demand EPDs for your building projects. Next, we look at an example of the embodied carbon in one of our products called SMARTPLY Pro Passive, which is a certified airtight OSB. So in this table, we can see that this is the LCA, the life cycle assessment results for SMARTPLY Pro Passive. And what this table shows is the environmental impact per ton of that material. So I'm only going to show the first line in this particular slide here before moving on to a bit more detail. So you can see here, GWP, global warming potential F, it stands for fossil fuels. This is the carbon footprint that we emit to make 1 ton of the material. The units are kilograms of CO2 equivalent. So this includes methane as well as other global warming emitters. So we total them up into GWP. And they are broken down into 3 stages, A1, 2, and 3. A1 is the materials, A2 is the transport, and A3 is the manufacturing of those materials to give us a total. So we can see that the total carbon footprint to manufacture SMARTPLY Pro Passive is 439 kilograms of CO2 equivalent per ton. And in this graph on the right-hand side, we can break that down even further. We can see that the materials here in the green, you can see the resins, the release agents, the wood content, the UV coating. This gray part here is the transport of those raw materials to site, and this orange section here then is the processes that you can see here. So the forming, the pressing, the cooling, the cut to size saw, the UV coating line, and so on. So this is a full declared picture of the carbon footprint of that product. So the embodied carbon footprint is the amount of carbon or CO2 equivalent emissions to produce 1 ton of SMARTPLY Pro Passive. So in this next slide, we take it a little bit further and we look at going beyond the fossil-based emissions. Wood is truly unique in that it sequesters carbon as it grows, as I mentioned earlier on, and this is called biogenic carbon, and it's important that this is reported separately in the EPD. So the small b here you can see means biogenic carbon, And again, we total this through the stages. You can see here that A2 and A3 don't have any biogenic carbon because it's only the material that has the sequestered carbon. And again, we total this through, and you can see it more clearly on the graph here. The positive carbon footprint is 439 kilograms, and the sequestered or biogenic carbon comes right down to minus 1640. This is the carbon storage in the product, or the biogenic carbon in the product, which gives a net of the two of minus 1200 kilograms of CO2 equivalent per ton of that material. So by this, we can say that the product is carbon negative to the factory gate, which is A1, A2, and A3. More carbon is stored in the OSB than was emitted from the production processes. And the carbon is safely stored for the lifetime of the building. And this biogenic carbon, as I said, it must be reported separately, and that's to ensure the comparability and to prevent double counting in whole life carbon assessments. And this is also important, that end of life carbon release should also be considered. So we're saying that the product is carbon negative to the factory gate, but by giving all the values in the EPD, we're now enabling whole life carbon to be counted and measured and declared for building projects. So only wood and other natural materials can be carbon negative due to this biogenic or sequestered carbon as trees grow. So here's the output then from a whole life carbon assessment software tool called One-Click LCA. And again, without going into detail, but you can see here, if I just highlight the same figure here that was in the EPD, 440 kilograms of CO2 equivalent per ton of the product comes through. And you can see here the biogenic of minus 1640 kilograms CO2 equivalent is reported separately in the assessment software. And to put this into reality then, so this is where embodied carbon meets operational carbon in a real life building product. So by calculating and counting the embodied carbon in the product, we now can put a figure to that in a real building. But where operational carbon comes in is where this is the product that Propassive has been used as the airtight board on the walls and the ceiling. And this helps to reduce embodied carbon dramatically, because we know that 50% of heat loss in buildings is as a result of air leakage in the building. So by putting an airtight board in the building, you dramatically reduce the heat loss in the building by up to about 90% compared to typical buildings, or 60% from current building standards. So not only does this improve the embodied carbon of the house, the operational carbon is dramatically reduced as well by the airtightness. And this also, by having an airtight layer in here, you also improve the efficiency of the insulation material dramatically, because you're preventing any air from escaping through the material. And there are other things that Isabel will talk about in her presentation later on, such as reducing thermal bridging and so on, which all count into operational carbon figures. So if we look at a house that's being built under construction at the moment, a timber frame house, and if we try to set a target of achieving net zero carbon for the house, we can break it down into a couple of different areas. The first one is operational carbon, as I mentioned, and this is very well controlled by Part L of the building regulations. And this pretty much focuses on energy efficiency of the building. So heat loss, air tightness, thermal bridging, and so on, coming through the walls and the roof and the floor. And this is all to do with the operational use of the building. So your space heating, your hot water, your cooling, your lighting, and your power. Then you tack on some renewables. So if you're looking at putting 100% renewable energy, it may be PV panels on the roof, it may be an air source heat pump outside, or it may be even a high content of renewable electricity from the grid. And that should equal net zero carbon. But does it really? It's obviously net zero carbon operationally, or operational net zero carbon. But there's one big part missing in this, and that's the embodied energy of the materials and the manufacturing that go into making up the house, as well as the construction practices on site, and as well as maintenance and renovation and demolition at the end of its life. So these currently are not counted in the building project. And that's really the emphasis that we're trying to place on this webinar, is that the embodied carbon of materials do need to be regulated now, and the tools and processes are already in place to allow that to happen. Finally then, just to give you a very brief introduction to a project that we've just launched very recently called Project Net Zero. This is an exemplar case study of a high-performance timber frame passive house that's being built in County Wexford, and we're delighted to be working with Isabel, Barros architects on this housing project. It basically uses low carbon materials throughout the building fabric. So you can see here, I-joists have been used in the walls and roof structure. SmartPly Pro Passive and MEDITE Vent have been used, and wood fiber insulation throughout, including around window openings and so on. So there's a lot more on this project to come. Isabel will explain in detail on the design and technical detailing of the house, but keep an eye on my LinkedIn page and on MEDITE SmartPly's website for more details to come on this exciting project.
Thank you for going into so much detail about where your products come from. I think we all know that we want to avoid waste wherever possible. And I am aware of the fact that large timber elements leave a lot of the tree unused. So I think it's really interesting to see how you are using thinnings, etc., and making as good use of the material as it is possible to do. And thank you very much also for flagging up the next project, which we will hear about in one moment. I just first want to remind everybody to keep sending in those questions because after Isabel Barros has spoken, we will have our roundtable discussion and we will address as many of those questions as we possibly can. So to hear about the exemplar project, we now have Isabel Barros of Isabel Barros Architects. Over to you.
Well, thank you for inviting me to come to talk about our project Net Zero, which is a family home and it is currently on site. So the target for this project is to achieve net zero carbon emissions. I want to introduce you the project, and I'm going to be giving some information about the site location, the concept design, and then we'll move to the technical design and specifications, and we'll finish with the construction and some photos of the works on site. The site is located in the Republic of Ireland, in Wexford, County Wexford. Wexford is known by its strawberries and also by being the sunny southeast of Ireland. We don't have strawberries on this site, but we do have plenty sun when the sun is shining, obviously. The site itself is of Ireland, although it's only 10 kilometers from Wexford town, but it is surrounded by large fields, open fields that are delineated with native hedges and trees, and there are also a few farmyards nearby. The house is a modern interpretation of the traditional courtyard farmyard. So we have the courtyard there and the house, the main house at the front here, enclosing the courtyard together with the garage at the back. And we have a straight driveway to access that courtyard. The site presents a south-facing slope, offering open views in a rural landscape. And obviously the south-facing aspect of the site offers good access to solar radiation and daylight. The northern boundary presented a bit of a challenge because we had quite significant row of trees, mature trees that were maybe 6 meters high. So we were a bit concerned with the impact of the shading that would cause, and some of the so we did a few shadows like this one to ensure that we would locate the house in such a way that will not receive the shadows from those trees. Getting into the concept design, then we wanted to create a strong relationship between the house and the landscape. So we were quite inspired by the trees that are on the northern boundary and by the rhythm that they created and the repetitive pattern. So that kind of inspired the design from the start. And we end up with 3 main volumes that are not only by traditional elements and forms and its simplicity. Being our first passive house, we were a bit concerned that we would have to be restricted by boxy volumes and interesting type of forms. But as soon as we did the concept design, we consulted with the passive design consultant, and we were happy to find that everything was okay. So it was a very good surprise to know that our creativity didn't have to be restricted just because it was going to be a passive house and a zero carbon building. What we used externally, it was a very simple palette of materials that were very related with the local materials that we have nearby. So we have rendered surfaces, white rendered surfaces, and we have some notes of rubble stone, you see there, and corrugated metal. The aim was to connect the cultural and local values with a more contemporary built environment. The two-story volume that you see there was a bit somehow challenging. We wanted to mimic the agricultural buildings in the area, and that helped to reduce the visual impact. So we selected the materials very carefully, and we play with the mass and weight. And at the same time, we're playing with present and past and trying to connect all these traditional elements that were part of the rural architecture. Moving to the technical design and specification, it was very early decided that the house was going to have a timber frame structure. And this decision was based in a number of reasons. We were obviously, and we are confident that wood is the construction material of the future, and it made also to achieve a zero carbon building. It is a recyclable material, it is renewable, it has low embodied energy, lighter carbon footprint, there is less construction waste, and there is a quick build time. I think they took 3 or 4 weeks to assemble the whole structure on site, which was amazing. And then this obviously allows the introduction of the following trades much earlier. So we could only see advantage with this type of structure, particularly when working towards the net zero carbon ambition. The next decision, or maybe not the next, maybe it was nearly at the same time, was about the building envelope. So what specifications these would have. The floor itself, we went for 300 millimeters of EPS insulation on the floor, and for the foundations, we used an insulated foundation system. And these EPS blocks that you see here, they wrap entirely the foundation of the building in a continuous layer and virtually eliminates all the thermal bridging at that junction between the wall and the floor. The next part of the building envelope that I want to talk to you about are the walls. The walls we had many discussions about the walls, and many options were explored. And at the end, the decision that was made was to use the I-joists. So you see them here. The I-joist has the timber frame structure there. And externally, represented by an orange line there, we have the MEDITE Vent MDF panel, which is a diffusion open panel with high racking strength, and it has excellent vapor permeability properties and excellent weather resistance. So it is ideal for timber frame structures. So this was outside, and then our breather mandem and our block wall. Inside, the panel was closed with the SMARTPLY Pro Passive panel, which is this green line you see here. And this is a structural OSB panel with the integrated vapor control and air barrier properties. So it does replace your standard membrane that you see in timber frame construction. And so this panel was built in the factory, it was closed, and then inside it was pumped with wood fiber insulation, and that was done on site. And also inside we have the service cavity where we installed wood fiber boards, and then we closed it with Fermacell boards. So it was a fantastic wall to work, and the timber manufacturer was able to achieve great finish with this. Now moving to the roof, we also have the SMARTPLY pro-passive panel there, and our service void inside, and then the attic was filled with the loose fill wood fiber insulation, 400 millimeters of insulation. We also had other types of roof, a vaulted ceiling roof and a flat roof, but we don't have time to go through them all now. This is just an overview of areas and ratios and U values. You see, we achieved a ratio of window area to building envelope area of 5.62%. And the ratio of window area to floor area, it's nearly 19%. The windows facing north, we only had one window and the front door facing north. So that was to avoid heat losses. And most of our or nearly half of our windows were facing south, 49%. Regarding the U values, and if we exclude the windows for the moment, the highest U value we have for the walls is 0.119, which is still far below the maximum that we could have in Ireland. All other values are less than these. The windows are 0.78, it's the U value for the windows. They are alu-clad windows, triple glazing everywhere. And they have airtightness class 4, which is the highest class you can get. So they were really good windows. The technical building systems, we have a mechanical ventilation with heat recovery system, and we have an air source heat pump providing underfloor heating downstairs and wall heating upstairs. The heating is not really needed according to our calculations, but we had to provide heating to comply with the Irish building regulations. We will be also installing photovoltaic panels. And regarding passive systems, we have solar shading in the south elevation. And this comes by means of canopies that project out about 500 millimeters. And internally, we have blinds as well on those windows. Moving to construction, I want to talk to you about air tightness and thermal bridging. Obviously, for a building to be of a very high energy efficiency, the envelope must be airtight, and the airtightness does not start at construction. It starts much earlier at the technical design stage. So we want to make sure that there is a airtightness strategy and there is a single continuous airtight barrier around the building envelope. So I just want to show a few examples of how we dealt with this. Here we see the airtightness of the building structure. So we see at the left, we have the panel that was manufactured in the factory. You see that the green panel is the SMARTPLY Pro-Passive. So our air barrier strategy relies a lot in this panel, which is airtight. And then the junctions between elements were designed to be joined using membrane and airtightness tape. So that's what you see in the photo here. The photo to the right-hand side shows the panels already on site, and you see the holes are not yet sealed there. These are the holes where the insulation is going to be pumped in, and the window is not there yet as well. And it's also missing here the ceiling between the floor and the wall that will go around there. So this is not yet airtight at this stage. This is one other detail showing the ceiling between the windows and the wall. So that was done by airtightness tape around the perimeter of the windows there and there. And the last example I have to show regards the ceiling of the service penetration. So you see that was done there as well. And special care needs to be taken to ensure that there is no leakage through these penetrations. And this is very important. And our contractor on site had this quite interesting quality assurance thing that's what you see on this photo on the right-hand side, where he had these notepads for every trade, the plumber, the electrician. So the idea is that they would note every penetration that they have made there in that list, so they could then go after, they would know where they were and they could seal them properly. So that was extremely helpful as well. It's important to do a blower door test to identify major leaks. So by the time the test was done, see, those holes were already sealed there. So everything was completely sealed and ready for the test. And the result we got was 0.08 air changes per hour at 50 pascals pressure. So it was a very good result. I was told it was the best air change ever tested for a home. And we have to recognize that SmartPly Pro Passive, those green panels there, played a huge part in the result together, obviously, with the attention for detail and the quality control from the contractor. Regarding thermal bridges, they play a crucial role in terms of the building's energy efficiency. All edges, corners, connections, penetrations, they must be planned and executed with great care, so the thermal bridge can be avoided. Again, this does not start at the construction stage, it starts much earlier. Here I'm just showing you a few examples. This is the EPS insulation that wraps the foundations. So that's the piece, how it comes to site. And then it's installed around the perimeter there. And it minimizes or eliminates the bridge, the thermal bridge between the floor and the wall. On the left-hand side, we have a detail showing how we dealt with the thermal bridge at the threshold. So you see there is insulation there, structural insulation installed at the threshold there. And you see the photo of these on site. It was already covered with the tape and membrane there. This is another example of the thermal bridge, how it was corrected around the windows, the opening. So this is a photo taken on in the factory before the panel was closed. It is a wood fiber board that wraps the jambs and the seal and the head of the window. The last example I want to show you is the roof. We use the raised heel truss, and these allowed us to have continuity of insulation between the wall and the roof there. So at the top you see the roof before the insulation and the raised heel there, and at the bottom it's after it was pumped with the wood fiber insulation. So to finalize, I want to review with the main points that I see are important to design for a zero carbon future. Obviously, the very important is to have a fabric first approach. So we want to have a well-insulated building envelope. We want to have high energy performing windows and doors. And we want to minimize heat loss through thermal bridges and reduce air infiltration and look at the air tightness strategy. Looking at specifying materials with high recycled content and with lower carbon intensities, it's halfway to get to our zero carbon ambitions and goals. It also helps to select materials with lower transport related carbon emissions. And we would recommend using EPDs to understand the impact of a product. And I think that was already discussed during this webinar. The airtight and thermal bridge free design are fundamental to achieve a zero carbon construction. So let's not forget about these. And one thing that is not only like to mention is that is also important is team collaboration. So if everyone understanding what is the airtightness, what's the importance, and making sure that they are responsible for whatever penetrations they have done, and they come and they know that it's important to seal them and so on. Also important for this project was to have like-minded clients, that they were always trying to achieve the best, always trying to reduce their carbon footprint and so on. So that was very important for this project. So I want to end my presentation just to leave this quote, and you must be the change you wish to see in the world. So I believe that architects have a key role in fighting climate change. we can have a big impact in the construction industry just by pushing the boundaries and specifying solutions that help to achieve net zero carbon buildings. And there are many solutions out there, so don't be afraid of using them and change the world. Thank you very much.
Not surprisingly, there have been questions coming in specifically for Isabel. So I'm going to bring all our panelists back together in a moment. Here you all are. But I'm going to go to Isabel first because somebody said, thank you so much for all the presentations, which I absolutely echo. That's to everybody. Amazing. And they've asked what the cost per square metre for the building the house in Wexford was. And, you know, someone else has said, you know, what were the costs of the client for this house? Do you need to bend expectations much or count on the client to lead the move? In other words, I think we'd love to know how much it costs. And really, is it a lot more expensive than anything else? And how do you win that argument with the client if it is?
That's a very good question indeed. I don't have the cost at the top of my mind. I think we are between 1,800 per square meter and maybe 1,900. Could be touching 2,000 euro per square meter. I don't have the figures, the final figures right now. But surprisingly, I think it wasn't. I think no, I'm sure that it wasn't more expensive than other traditional methods. But there was a lot of work involved to get to that stage. But it wasn't that much more expensive, no.
I think related to questions of costs, and I think I'm going to go to Pat first on this. I mean, we've had people asking questions about, you know, how difficult it is to justify, you know, retrofit when you look at a payback period of at least 20 years, and people saying, actually, don't we just need more? Isn't the only way we're going to get this improvement to come through more regulation? And sort of someone has also talked about shouldn't EPDs be compulsory? And I'd just like to get your view on that.
Thank you. That's a good question. I suppose I'll take the first one last. I think we are moving towards, at some stage, having requirements for EPD. The European Union is currently reviewing the construction products regulations, and we may see a requirement for some form of either the EPD or the product environmental footprint come out of that. In terms of moving towards renovation, I suppose we already have a requirement for major works within Ireland anyway, where major works are carried out to a home, that you do have to bring the whole home up to a certain standard if you're carrying out work to more than 25% of the surface. So I think we'll have to move towards probably setting performance standards for the existing stock. And we would expect to see that happen, particularly for rental properties. That would probably be a requirement of the revised Energy Performance of Buildings Directive. And we will probably see requirements, particularly for, certainly in the commercial space, for requirements to declare the actual performance of those buildings that will start to force renovation.
Somebody's talking about the difficulty in trying to use recyclable materials and saying in rainwater goods that actually UPVC downpipes have lower embodied carbon than products that can be recycled. But, you know, basically they're saying things like aluminium can be recycled. But are we being pushed to use things like PVC because it has a lower embodied carbon? Have we got the right system for this?
Thank you very much, Ruth, for the question. I would like to say that it is important to have the whole building life cycle assessment where we can look into the emissions through the whole life of the building, and the recyclability will be taken into account in this assessment. So, for example, aluminium can be recycled, but even when it is recycled, you still need energy to produce the new product from the scrap. Even if you need much less energy, it probably several times less energy than for 100% virgin material production, you still need high intensive energy to produce the new material from the scrap. That is why it may happen that in some cases at the end you may have actually lower embodied carbon for the new product than from the recyclable product because of that. So I would say that it's very important to look into the whole building life cycle assessment results, and there you can just compare two options, and then you will have global warming potential for both options, and you can choose which one will be which will have lower embodied carbon.
We all have a tendency to think, oh yes, this is good, this is bad. And I think we really are moving to a point, aren't we, where we have to really go with the numbers and not just go with our guts. Someone else has asked a question, and I think I might put this to you, Daria, as well. They're asking about insulation products, and they're saying, with wood fibre insulation, how much thicker does that have to be than some of the other more conventional insulation products?
This is a very specific question on the insulation, and I think it depends on which insulation types we're talking about, what exactly we're comparing. And because, for example, one of the fiber insulation types, it may be sprayed insulation from the recycled paper, and I think that it can be the layer thickness will not be very large. So I would say that we would need to compare the specific application as well, because obviously not every insulation type can be applied to every specific application that we need for the project. But then we can compare the specific case, how it will be used, where it will be applied. Is it external walls? Is it internal walls? Is it roof insulation? Is it basement insulation? What is it? And then we can look what are the options that are available that can actually be applied there. And then we can compare the specific products and specific insulation types, because obviously fiber-based insulations, there are many different options, and as well as synthetic insulations, you also have a lot of different options there that are available.
Somebody's saying emissions of timber are already calculated from when the wood is harvested. Why would it be a problem when wood is burned with the energy use at the end of life? And someone else is asking, what can we actually do with timber at the end of its life to ensure that the carbon remains sequestered?
Yeah, look, I think the important thing here is to keep timber in use for as long as possible. That's the first thing. If you burn wood in a stove, in a wood burning stove, for example, that's obviously at best, I guess, carbon neutral. So the carbon is released pretty much straight away back into the atmosphere. But obviously, by putting it into sustainable building products, and by what I mean by that is wood products that have been sustainably and responsibly managed, that carbon is locked up in that building product for much longer than 60 years, which is obviously the assumed lifespan of a building. We have examples of timber buildings lasting hundreds of years, not tens of years, and that's way before this carbon argument ever started. And then the other part of that question is, in terms of end of life and circularity. One example of what MEDITE SMARTPLY have done is we've developed a product called MEDITE Tricoya Extreme, which is guaranteed to last outside for 50 years minimum, which means it's obviously going to last a lot longer than that. So your maintenance is reduced on the product, and the product remains in place for much, much longer. And you couple that with things like reusing or repurposing buildings. So as Daria mentioned earlier on, I think we're designing buildings, or we should be designing buildings for taking them apart at the end of life, and then recycling that material. So wood can be recycled at the end of its life. There's new technology coming on stream now for reusing MDF fiber that comes back from the market and so on. That's being commercialized at the moment. So there's a lot of good stuff happening there in that space.
My understanding is that the reason that you have to look at the sequestered carbon on a different line is because one way or another you still have to calculate it as being released at the end, so that you don't double the count. In other words, if it goes into another building, you're not getting the advantage twice. Right. Here's a question you won't like. I think you can demolish it, but we'll see. It says, it takes them 10 to 20 years for trees to grow until they're large enough for harvesting. Sequestration is greenwashing. We don't have 20 years.
We don't have 20 years. We have to do that now. And that's the whole point of embodied carbon, is that we're making assumptions that at the end of life, wood products are going to be reused, but we don't have 60 years to wait here. We've got to do this now. If we, what's the alternative? If we don't do this now, we lock up as much carbon as possible, then, yes, 15, I think it's 12 to 15 years actually for first thinnings in a forest. So as I mentioned in the presentation, taking out those thinnings is the best practice in sustainable forest management. So you allow the rest of the forest to grow to its full potential, and that plantation, depending on the species and the location of the forest, will last 40, 50, 60 years, or in Scandinavia much longer than that. So the sequestered carbon in the forest is there for much longer. But the whole point is here that, again, in terms of, I keep going on about it, is sustainable and responsible management of forests. It's not a case that we're cutting down trees, putting into buildings and not replacing them, which is why it's really important that when you're specifying timber, it must be certified, independently certified as FSC or PEFC or other recognized and independent certification scheme. So then you're guaranteed that the trees you're taking out of the forest are being replanted more so than they're being cut down. So in other words, the forest estate is growing all the time. But the key point is here, yes, we have to do it now, and that's why embodied carbon needs to be taken into account. We need to get more timber into buildings.
That's great, thank you. I'm going to come back to Pat with what I think is probably our last question. And it actually came from something that Isabel said, which, I mean, no fault to her at all, but I thought it was a little bit shocking, that she's designed this house, and actually she doesn't feel that it needs any heating in it, but regulations insist that she puts it in. I mean, we've been talking, and you talked to us very clearly about how we need to make some of our regulations stronger. Do we also need to be more flexible to understand what we're doing? Because, both in terms of cost and in terms of embodied carbon, we don't want to be putting things in our buildings that we don't need, do we? Just as, Daria's presentation says, we don't want to put suspended ceilings in if we don't need them, because actually they're a real nuisance and they keep needing to be replaced, and that's not great either. So how should we be thinking, Pat? What should we be doing next?
Well, I think that's a good question that applies generally to regulations. How do we make regulations more effective? Essentially, regulations are there to protect the consumer and to protect people. But in some cases, and it's not just in that case, but even embodied carbon, they can get in the way of innovation. So we have to look at regulations that are set up that they protect people, and we have that balance of protecting the consumer, but also making sure they're effective in delivering in the intent. We can look at things like regulations can, if we're having a particular issue, say in Ireland at the moment, looking at trying to develop solutions for cross-laminated timber or mass timber construction. We can't build anything above 10 meters in CLT. So currently our regulations are acting as a barrier. So we do have to look at our regulations in a 1.5 building within a 1.5 degrees restrictions. We're going to have to make our regulations both serve the environment and protect the consumer.
Thank you very much. I think that does give us all a lot to think about, and I hope to act on, whether it is acting at the level of innovation that we have seen from David and from Isabel, whether it's from the pressure that needs to come to change the regulatory environment and continue to change government thinking, whether it's from the knowledge that people like Daria are bringing us of a real understanding of materials and the advice on what we can use. I think that's been a really valuable event, and on behalf of Architecture Today, I would like to thank MEDITE SMARTPLY, obviously, for making it happen, but actually all of the speakers who have given us such great presentations, all of you in the audience as well, both for watching and to all the people who have submitted questions. I hope to see you again at another event fairly soon. Thank you very much to everyone, and goodbye. Thank you.